Hello students, this video is designed to help you with parallel line proofs. This is in the third unit in Common Core Geometry, and I hope that it helps you out with the problem set. I know that we were going over these problems in class, and some people had questions on them, so I hope that this helps. Just like any other problem set, I would like you to attempt these questions on your own first, and then once you do the questions on your own, you can check out this video for the correct answers. The first thing that we did in class was to prove that x, w, and z were equal to 180. This was something that we did in class, but if you were absent or you didn't happen to do it, if you're a student from another teacher, pause the video and try to write out this proof, and I'll show you the correct response in a moment. All right, I've led into this by circling the prove statement. It asks us to prove that x and w and z add together to give us 180 degrees. And on top, I've written some notes. We're going to talk about that in a moment. I've written some notes about what could possibly give us 180 degrees. Supplementary angles are something that we've talked about that gives us 180 degrees. Triangle sum theorem is another possibility that gives us 180 degrees. And just looking at this diagram, looks like I have a triangle. We are able to mark off the different angles in this triangle. X, Y, and Z are all here, and they sum to 180. And the reason that we know that is because of the triangle sum theorem. The second step was to say that angle W is congruent to angle Y. The reason we know that this angle and this angle are congruent is because of vertical angles. That's a classic vertical angle shape with that X of two intersecting lines. Once we do these two steps, we can identify the fact that angle Y and angle Y is the same in both. So what we did was we took angle Y out and replaced it with angle W. So we got angle X plus angle W plus angle Z is equal to 180 with substitution. Notice that we've gotten the same exact equation as what it says in the proof statement. So we are done. In the discussion, we asked you to take a look at this problem and try to prove that MN is parallel to PR. The first thing that I would like to model for you is taking a look at the stuff that's in the problem. It says it is known that MPQ is a line. It tells us that angle 1 is congruent to angle 3. The first thing I'm going to do is mark that on my diagram by putting one arc here, 1, and one arc here for 3. So those two angles are congruent. It also tells us that segment PR bisects QPN. And we know that bisects means it separates it into two equal angles, each half the original. So if it bisects QPN, here's QPN, that means that angle 3 and angle 4 are actually also equivalent. We have one arc here, one arc here, and one arc here. All three of those angles are equivalent to each other. So what we're going to do is set up a statements and reasons diagram here to try to prove that these two lines are parallel, keeping in mind that what we're trying to do is look at MN and PR, which is this line here, line segment, and this line segment. We need to try to use some sort of theorem to prove that these angles are congruent or these angles are congruent. We need to take a look. So pause the video for a moment and then check back for the correct answer. All right, the first thing that we said in our proof here were the givens. Angle 1 is congruent to angle 3 and PR bisects QPN. Those two things were given. The next thing that we said, this green step, is angle 3 is congruent to angle 4. That's 3 and 4 respectively because of the definition of angle bisector. Cuts it in half, makes it two congruent angles. The next thing we said was that angle 1 is congruent to angle 4. And when you look at the two equations up here, we can see that both of these say angle 3. So if both of these say angle 3, then both of these angles are going to be congruent as well. That's called the transitive property. I transferred equality from angle 3 to angles 1 and 4. So they are now congruent. I transferred congruence, I guess I should say. The next and final step that I can state is that MN is parallel to PR. That these two lines, vertical lines, indicate parallel. The reason I'm able to say that is because of corresponding angles. Check this out. Here's PR, and here's MN. I can imagine that this is a transversal. The line QPM is a transversal. If I do that, then I recognize that angle 4 and angle 1 occupy the exact same spot on my diagram, the exact same position. We talked about that in class, position. If this position and this position are both congruent, that means that these two lines must be parallel. So that proves that these two lines are parallel, or line segments, I should say. All right, moving on to the model problem. Pause the video for a moment and I will show you the proof. The first thing I did was annotate my problem. I wrote that AB is parallel to CE, and I also circled the proof statement 2 plus 3 plus 4 is equal to 180. I wrote some notes down based on 180. I know triangle sum theorem, supplementary, or consecutive interior angles all deal with this 180. I decided to go with the supplementary idea because it looks like these three angles are supplementary. You could have done this using triangle sum theorem. I know that many people in class did that, but I chose supplementary because I thought it was an interesting proof. AB is parallel to CE, as I said it was given. Angles 3, 4, and 5 equals 180 because they're all along this straight line. The next thing that I saw was that angle 2 and angle 5 are corresponding angles. And if you're having trouble seeing that, take a look at the thing that I drew here. It looks like these two lines are parallel, as it says in the givens. I know that these two angles are corresponding based on the fact that this is the transversal, and they're both on the right-hand side on the top of the transversal. The next thing I said was angles 3, 4, and 2 are equal to 180 due to substitution. If you'll notice, 3, 4, and 5 up here, I took out the 5 and I replaced it with a 2. And now I'm done because the proof statement said 2, 3, 4, and my statement here says 2, 3, 4 is equal to 180. Take a look at the next problem. This was the check for understanding. I'll pause the video and so should you, and then I will show you the correct answer as soon as you unpause it. All right, the first thing that we wrote that A is parallel to B and B is parallel to C because that's given. Keep in mind that we circled that proof statement. The next thing that I marked on this diagram here, before I say that, you can identify that these two lines are parallel by giving them one arrow each. You can identify that B and C are parallel by giving them 2 arrows each. But notice that A has this 1 arrow, C has this 2 arrows. We're not quite sure that A and C are parallel. In fact, it asks us to prove that. We don't have any theorems yet that tell us that we can transfer parallelism, only congruence. So, the next thing I identified that angle 1 and angle 2 are congruent basically because of alternate interior angles, and we know that because we can write that Z. We call it the Z theorem sometimes in class because we're cool. The next thing I noticed is that this transversal hits these two parallel lines. We know that B and C are parallel because of these 2 arrows. Hits these 2 parallel lines and identifies 2 and 4 as being corresponding angles. Once I identify them as corresponding angles, I can basically write the rest of the proof from there. Angle 2 is congruent to angle 4, which of course means that I can take both angle 2's and identify angles 1 and 4 as being congruent. They're transitive property congruent. Step 5 is that that line A is parallel to line C because of alternate interior angles. Don't believe me? Check this out. Here's a big Z identifying angles 1 and 4, respectively. Now, we weren't able to draw that big Z at first because we didn't know that A and C were parallel, but once we know that these two angles are congruent, we know that the lines must be parallel. So that was the first part of the lesson. Take a look at the problem set. I'd like you to try to do these on your own. Take a minute to do them, and then unpause the video, and I will show you what to do. All right, the first thing I did was annotate my problem. I underlined lines M and N are parallel. I circled the prove where it says angles 1 and 3 are supplementary, and I labeled my diagram with these 2 arrows that indicate parallel. M is parallel to N, which is given. The next thing I decided to do was choose linear pairs as my method of solution because I see a linear pair right here. I don't see any triangles. So angles 2 and 3 must be supplementary because they're a linear pair. So angles 2 and 3 are equal to 180. The next thing I did was I saw this Z, and I know that these 2 lines are parallel. You know that that Z theorem indicates that these 2 angles are congruent. So my next step is that angle 1 is congruent to angle 2, alternate interior angles, Z theorem. The last thing that I did was I identified angles here. Angle 2 is in both of these equations. So I decided to take 1 and replace 2 with it. In other words, angle 1 plus angle 3 is equal to 180 using substitution. I've proven that angles 1 and 3 are supplementary because supplementary angles add up to 180. Easy. Take a look at the next proof. It asks us to prove that M is parallel to N. Pause the video, try it out, and I will show you the answer in a moment. All right, the first thing I did was I circled that prove M is supposed to be parallel to N, so we can't use that as a fact. But we're not really sure what our givens are. Notice that it doesn't have any givens. I labeled that A is equal to 42 and B is equal to 138. The reason I chose A and B was just because I wanted to use those letters. As a note, whenever you're given information in a diagram, that's still given. And if they don't name the angles, give them a name. A and B is good enough. Measure of angle A is equal to 42. Measure of angle B is 138. That's given to us. It's in the diagram. We're allowed to use it. The next thing I notice is that this angle here is going to be supplementary with angle A. And I don't have a name for it, so I'll name it C. I'll put that over there. The next thing that I was able to figure out was that since these two are supplementary, I could do 180 is equal to, 180 minus 42 is equal to 138. So my next statement was that the measure of angle C is equal to 138 because of linear pairs, supplementary. I know that 180 minus 42 is equal to 138. Next, I identified angle C and angle B as being congruent because they both have that measure, 138. So angle B is congruent to angle C, congruent angles. They have the same measure. As a quick note, anytime two things have the same measurement, they're congruent to each other. So as soon as I say B has 138 degrees and C has 138 degrees, I can say that B and C are congruent because congruent means same measure. Next, I identified these two parallel or possibly parallel lines. And if I draw the transversal, I see that these two angles are in corresponding spots. Since the corresponding angles are equal, it must be parallel. M is parallel to N because of corresponding angles. Not bad. Let me fix this. This is supposed to say 180 minus 42. I hope that wasn't bothering you too much. Take a look at the next proof. It gives us that angle 1 is equal to angle 3, and angle 2 is equal to angle 4, and asks us to prove parallelity. Parallelism? Pause the video. Alright, we identified that AB and CD are possibly parallel. We identified that these are the givens, and we labeled it on the diagram, and we wrote out the givens. The next thing that we should have identified is that these two angles are comprised of 1 and 2 and 3 and 4, respectively. Those are the angle addition postulate when DCB is equal to 3 and 4, and ABC is equal to 1 and 2. Another thing that we should have noticed is that angles 1 and 2 are equal to angles 3 and 4, respectively. So that means this 1 can be replaced with a 3, this 2 can be replaced with a 4. So angle ABC is equal to 3 and 4. Well, check this out. 3 and 4, 3 and 4. That means these two angles are congruent because they're equal to the same things, which, of course, is the transitive property. Once we see that these two angles are congruent to each other, we can identify on the diagram that since the angles are congruent, these two lines must be parallel by that Z theorem again, alternate interior angles. Not bad. Taking a look at the next page, this is a proof that asks us to prove that Z is equal to X plus Y. Pause the video and I'll show you the correct proof. For this proof, you should have started by annotating, circling the proof, and writing down some ideas. We ended up using the auxiliary lines idea. We know that AB is parallel to CD. We know that Z is equal to A plus B. We identified A and B by drawing an auxiliary line here between at that point of angle Z. We knew that A and X were then congruent based on corresponding angles. They were both on the top right. We knew that B and Y were corresponding angles because they're on the bottom right. And then we were able to simply take A and B and substitute them out for X and Y. Keep in mind that auxiliary lines are a very important part of trying to do these proofs, these parallel line proofs. So make sure if you didn't review that lesson carefully. That was lesson 3. Take a look at proof number 5, pause the video, try it, and then come back and take a look. In the interest of time, instead of going through this step by step, I'll present it to you, allow you to pause the video whenever you want, and take a look at the reasons. Keep in mind that I've color-coded the reasons so you can follow along. Again, this is the last proof. I'd like you to take a look at this proof, pause the video, and try it yourself. Just like in the other proof, I urge you to pause the video to take a look at this and try to figure out what I did here. Everything is color-coded. Alright, these have been the parallel line proofs. Thanks for watching, and good luck studying.